Good evening. Welcome to Bzign Talks Day 3, organized by BIM Labs, the project division of BIM Labs, BIM Studio, as well as Bzign Club. I'll be speaking about the topic BIM for facilitating construction safety at site today. And I'm Bovis Birney, technical engineer at BIM Labs, and you can find me on LinkedIn at the handle mentioned in the slide. Our topic is BIM for facilitating construction safety at site. Despite numerous efforts to make construction sites safer to all parties involved, construction still remains as one of the most dangerous professions for workers. The culprit behind this is often said to be the dynamic nature of the industry, as in each project is unique and recognizing all risk areas and factors might not be possible, especially for the case of large construction projects. The workflow I'm introducing to you has the capability to deal with this dynamic nature of the industry, identify dangers at the design stage. Furthermore, the measures can be implemented and managed using a cloud platform on site. The tools we'll use for this workflow are Revit, Synchro software, as well as BIM 360. Our agenda for this particular session is I'll be explaining the objectives and summary, as well as the relevance of this particular topic, then the methodology and the software programs used, and what BIM Labs can offer you, as well as a question and answer session at the last. Speaking about the objectives, first we'll be evaluating the concept of BIM, in particular how it can be leveraged to benefit construction safety efforts. The next objective is to create a BIM model and simulate it in 4D, 4 dimension, to analyze the model for danger-prone areas and objects. Then measures for mitigating and eliminating these dangers will be taken in the planning stage. And third, we'll be incorporating the cloud-based platform BIM 360 for tracking the changes and the progress of actual construction and safety efforts. For giving a brief summary of this project, we will be studying the application of BIM technology to the life cycle of public works and construction projects and its effectiveness in on-site safety improvement efforts. We'll also look at 3D presentations, visualizations, and other similar methods as a means to mitigate risk. Also, cloud-based management of safety efforts will also be integrated into the workflow. Speaking of the relevance of this workflow or this topic, safety is a vital part of completing a project on time and under budget. Any delay caused due to absence of workers due to injury will affect the project adversely. Even the compensation and lawsuits may also drive up the cost much further than the company expects. But above all, the safety and health of the workers have to be ensured. So it's our responsibility to do or adapt whatever efforts we can to improve the safety of workers in the construction site. And if we're looking at the statistics, a study in the US says that out of every 5,000 private industry worker fatalities, 20% are in construction, which means out of 5, 1 of every worker death is construction related. So construction industry still remains one of the most dangerous industries or work areas in the world. Lack of proper safety protocols may be injurious not only to the workers but also to the general public who may be traversing nearby the construction site. Several construction projects in the past have incurred tens or even hundreds of deaths during its construction. For example, in 2015, A crane collapsed at Saudi Arabia's most construction, killing 107 people. And we might have heard about the Qatar World Cup construction. We know that huge amount of construction is going on in Qatar, and till now, the official death toll is reported as 34 for the all concerning all the construction works. The official death toll is 34 at present. So all these examples and points prove that construction safety is more important than ever. This slide shows the fatal four. That means the reasons which are the top causes of construction injuries or fatalities. The causes are falls, or the worker might be struck by an object, they might be electrocuted, or they might be caught in or in between an object. Falls might occur in excavation sites, and uh, for the second cause, moving parts of any object might be or might strike a person, as well as open wires might cause electrocutions, and moving parts and heavy objects might also cause injuries to the workers. Throughout this study, the concept prevention through design, or PTD, will be upheld. This is the concept on which our entire workflow is based upon. If I were to explain a bit further, this slide or this image shows a hierarchy of risk control measures that can be adopted. So at the top, the measures are the most effective, while going to the bottom, the effectiveness of the measures decrease. So at the top, we have the elimination risk control measures, then the substitution, engineering controls, administrative controls, and at the last, we have the PPE or personal protective equipment. Present measures are mostly focused on the lower rungs of this particular hierarchy, that's the PPE and administrative controls. BIM for safety planning is aiming for the top levels of this hierarchy, that is the elimination or prevention in the design stage itself, and depending on the feasibility, lower levels may also be considered. So we are aiming for a proactive effort to increase the safety of the construction sites instead of the reactive effort that we are seeing in a lot of present cases, where we adopt the safety measure after an accident has occurred. Instead, by using BIM, we will be making the appropriate changes and adopting the measures in the design stage itself. That's what the concept prevention through design is all about. If we're looking at the methodology of this workflow, the first step is creating the BIM model for the proposed building, and we'll be using Revit for this purpose. The second step is to export the building or the BIM model to project review software for visual coordination and studies. The third step is to identify the risk factors using a 4D simulation and to plan the countermeasures for mitigating all those dangers. The last step of a workflow is to use a cloud connected system, that is BIM 360, for ensuring construction safety at sites. The first step in our methodology, or the first tool we'll be using, is Revit. So I believe everyone is already familiar with Revit. Revit is the most widely used BIM software for designing buildings and projects. It's developed by Autodesk, and it's one of the most widely used software. So I believe it doesn't need much introduction. Okay, so after we build the BIM model or design the BIM model in Revit, we will be pushing the model onto Synchro. So Synchro is a set of or a portfolio of software and services developed by Bentley for mainly for the purpose of digital construction management. Through Synchro, it is also possible to develop 4D simulations, wherein 4D means we will add the scheduling or the time factor to the model or the simulation. Using Synchro, we'll get a day-by-day simulation of how the work will progress, and we will be able to identify work area overlaps, position of overhead cranes, obstacles, areas with electrocution risk, etc. And after identifying such areas or vulnerable areas, we can plan beforehand for measures, for adopting measures and mitigatory efforts to control or eliminate this risk. We can also plan beforehand, like setting areas for purposes. That is, we can set areas for loading or unloading activities for on-site traffic, or even site to public traffic transition points, placement of excavated earth, etc. So all these factors can be accounted for in the design stage itself using a 4D simulation of our BIM model using the Synchro software. So after identifying the areas of potential danger, icons or symbols can be placed on those areas in the 3D model, which actually tells us what the risk associated with this particular area. If you're looking at this further points in the slide, you can see that Revit to Synchro data transfer is possible through plugins. So Revit or Synchro has a wide interoperability feature. That means the Revit models can also be exported to Synchro through a plugin using the .spx format. And if you're looking at the product page of Bentley of Synchro, we can see that of the four main goals of this software or this portfolio of software, one of them is focus on safety. So improving safety is one of the main goals of this Synchro software, and it can be used effectively to that purpose. Also, Synchro XR, another tool related to Synchro, is capable of mixed reality when used in conjunction with Microsoft HoloLens. So this slide is a representation of the workflow between Revit and Synchro. At the top left, we have the Revit model, the BIM model created in Revit, and the subsequent images show the workflow in Synchro, wherein we can simulate the actual construction process in a day by or in a timely manner using a timeline. We can get a day-by-day schedule of how the work will progress and simulate it based on actual site conditions. And we can place icons, red, yellow, or different colored icons that specifies or which have their own meanings to the areas which are more risk prone or vulnerable. This slide shows a mixed reality capability of Synchro, wherein by using Microsoft HoloLens, we can achieve mixed reality, which is a step further than augmented reality or even VR, wherein the mixed reality or the virtual reality can be tethered to physical world and we can move it with our own hands, similar to the futuristic technologies we often see only in movies. The next step in our workflow is BIM 360. BIM 360 is developed by Autodesk, and like Synchro, it is a set of tools for collaboration and management. Different tools in BIM 360 allow us to manage the field, the documents, the 3D models, even through your smartphone, through apps. In the context of construction safety, through BIM 360, one can execute safety program checklist and site observations from his or her mobile device. The person can also track safety issues in real time, communicate delays and areas of concern to the office team all in real time. If the site engineer or the safety engineer finds an issue somewhere in the construction site, he can raise that issue to the company or the concerned person. If the issue is resolved, he can mark it on BIM 360 as resolved, and if not, he can raise it again for further consideration. This slide shows the different BIM tools available for BIM 360 tools available for various stages of construction. So this is the workflow for using BIM for improving construction safety at site. We created a BIM model in Revit. At first, we pushed the model into Synchro, a software by Bentley or a set of software by Bentley, created 4D simulations using timeline and identified the areas of danger risk areas and placed icons on the risk-prone areas, so that on the site, the engineer can actually navigate through this 3D model, identify the areas where the icons have been placed, and take appropriate measures. Even before the actual construction starts, the plan or the designers themselves can adopt measures so that these dangers can be eliminated or prevented. If I were to explain a scenario in which this workflow can be used, if today, if a particular work, electrical work was supposed to be completed today, and if there was a delay in the completion, then using BIM 360, the site engineer can actually update or inform the office that the construction has not occurred as per plan and the electrical works have been delayed. So there might be open wires or unprotected wires going through that particular area where the electrical work has been done. And if another team who have no foreknowledge of this particular electrical work going on, if if that particular team doesn't know that this electrical work is going on and actually works there, they are in risk of getting electrocuted. So instead, if you're using BIM 360, the engineer can update the delay in this work to the office in real time, and the office or the concerned people can make the necessary arrangements for the next team to work in a manner which accounts for the delay in the electrical work. So this is a basic scenario, or one of the most basic scenarios in which this workflow can be useful. But several projects have already used Synchro, Revit Synchro workflow, and even the BIM 360 added to improve the safety at the construction site. Okay, so there's a workflow I'm introducing to you today, in which we use BIM for improving construction safety at site. So I hope you all understood this particular workflow and the softwares involved. Next on Bzign Talks, we have a talk on construction management using BIM tools, 21st November 2020, or the next Saturday. So I encourage you all to participate in this particular webinar also. I would like to introduce you to BIM Labs BIM community too, where you can learn and unlearn and relearn technologies related to BIM. You'll get free training and seminars, design challenges, and knowledge evaluations and placement assistance related to BIM. So anything related to BIM, you can find that here. So it's a interactive community wherein, and I'm introducing you to it, and I'm encouraging you to partake in it. So thank you for attending the session and cooperating. So if you have any doubts, please do ask me. Okay. So if there are no doubts, I hope it's all clear to everyone who have participated. I thank you. I'm thanking you all once again for your participation and kind cooperation. So also please check the chat box for the feedback form uh, and also the BIM community links. Also, please do contact us for any further information on this workflow or other workflows. or we've already conducted. You can find us on the website of BIMLabs is bimlabs.in, and you can find us there. Okay, so thank you.